Have you ever wondered how your smartphone or tablet knows it is the time to lock or unlock the screen when you place or remove a magnetized case or cover? The answer lies in a tiny component called a Hall effect sensor. Let's understand how the system works. Hall effect sensors are tiny devices made up of semiconductor materials that can detect the presence of a magnetic field. Consider this N-type semiconductor, where electrons are the majority charge carriers, and positively charged holes are the minority charge carriers. When an electric field is applied across two parallel surfaces of this semiconductor material, the electrons are attracted towards the positive pole, while the holes are attracted towards the negative pole of the battery. While in outer circuitry, electrons flows from semiconductor to positive terminal of the battery. This is replenished by negative terminal of the battery by supplying electrons to the semiconductor material. If V is the voltage applied across the semiconductor bar, across two parallel surfaces, being at a distance of L apart from each other, then the intensity of applied electric field would be V upon L on the charges. Now, at this condition, if we apply a magnetic field across two other parallel surfaces, and perpendicular to the applied electric field, the moving charge carriers will get deflected from its path. This happens because moving charges, under the application of magnetic field, experiences a force called Lorentz force. The direction of deflection can be found using Fleming's left-hand rule. Fleming's left-hand rule states that if we stretch the forefinger, middle finger, and thumb of the left hand such that they are mutually perpendicular to each other, and the forefinger indicates the direction of the magnetic field, the middle finger indicates the direction of moving charge, then the thumb will show the direction of the force exerted on the charged particle. Due to this deflection of charge carriers, the concentration of negative charges are built near to the fifth surface of the strip, also near the surface parallel to this. Concentration of positive charge carriers increases. So, there is excess of electrons on one side, that is negative, and lack of the electrons on other side, that is positive. That's why an electric field is induced in the perpendicular direction to both E and B. This phenomenon is called Hall effect. The Hall-induced voltage, VA, is equals to EW cross D. At this condition, the force on a charged particle, due to Hall-induced voltage, attains equilibrium with the force on it, due to the applied magnetic field, B. Therefore, at steady state, the Hall-induced voltage is proportional to applied magnetic field strength. So, when you bring or remove the cover of your smartphone carrying a strip made up of magnetic material, the strength of applied magnetic field on the Hall sensor placed inside your smartphone increases or decreases. As a result, the value of Hall-induced voltage gets changed. This change in Hall voltage is used by your smartphone processor to operate the screen lock mechanism.
If you have found the video helpful, please subscribe the channel and press the bell icon.